Hi there, and welcome to our learning activity video on Math Packs for Senior High School General Mathematics. Our objective: the learner solves exponential equations and inequalities. Let's start. So we have here exponential equations, directions. Solve the following exponential equations and write your answer or solution in your answer sheet. For number 1, 9 raised to x plus 6 equals 3 raised to 20 minus 2x. Solution, we just copy. Then, we can express 9 as 3 squared. Then, we copy x plus 6, and that is equal to 3 raised to, factored out 2, so 2 times quantity, 10 minus x. Then, simplifying the left-hand side, we have 3 raised to 2 times quantity x plus 6 is equal to 3 raised to 2 times quantity 10 minus x. The objective or the goal is to have these two expressions on the left and the right-hand side a common base. In this case, the common base is 3. So since they are already in a simplified form with a common base of 3, then we can equate their exponents. Notice that the exponent here contains factor 2, then quantity x plus 6. Then another exponent contains also factor 2 and quantity 10 minus x. So, we can just equate x plus 6 equals 10 minus x, as reflected here. Then, simplifying the x, collect all x's on the left-hand side and all the constants on the right-hand side. So, we have here x plus x, 2x, then 10 minus 6 becomes 4. So, we divide both sides by 2, giving us x equals 2. So, don't forget to check if x equals 2 is actually the solution to the given inequality or exponential equation. For x equals 2, then we have 9. We just copy the original term. Then, we have to substitute x equals 2. This is 9 raised to 2 plus 6 equals 3 raised to 20 minus 2 times 2. Is this true? So, we are not yet sure, so we put a question mark. Then, simplifying 9 raised to 8, because when multiplying with exponents, in this case, we have to add the exponents. Okay? Equals 3 raised to 16, 20 minus 4, it's 16. But, we're not yet done because we need to confirm whether this expression are equal. So, we have to express 9 as 3 squared, then multiply it to 3 raised to 8. So, we have to add 3 raised to 2 times 8 is equal really to 3 raised to 16. And this is a true statement. So, next, hence, x equals 2 is the solution to the given exponential equation. Moving on to number 2, we have 9 raised to 2x equals 27. We have here solution. So again 9, let us express 9 as 3 squared. Copy 2x. And 27 is a perfect cube. So we express it as 3 raised to 3. So we have here simplifying this 2 times 2x. We have here 3 raised to 4x equals 3 cubed. So they have the same base. So all we need to do is to equate the exponents for x equals 3. Solving for x, we have x equals 3/4. For the checking, x equals 3/4. Then we have the original expression. We express already 27 as perfect cube of 3. So we have here 9 times 2 raised to 3/4. Is this equal to 3 cubed? Then we have here, substituting the value. Why do we have 3 raised to 2 here, other than 2 times 3/4? Well, 3 squared is 9. So we rewrite, or 9 is transformed into 3 squared, in which case this is allowed. We can do that. Is this equal to 3 raised to 3? Okay, question mark. 2 times 2, 4, divided by 4 will cancel out, becomes 1. So giving us 3 raised to 3. And on the right hand side, we just copy, and it's a true statement. So hence, x equals 3/4 is the solution to the given exponential equation. Number 3, 5 raised to x squared minus 6x is equal to 1 over 25 raised to 4. Copy. Then we express the side 1 over 25 is actually equal to 5 raised to negative 2 exponent. So again, raise it to 4. So we just transform 1 over 25 into an exponent with a base 5 with exponent negative 2. So they have now the same exponent, 5 raised to x squared minus 6x, and then 5 raised to negative 8. We just simply multiply negative 2 times 4 to get negative 8. Since the expressions have already the same base, we can equate now x squared minus 6x equals negative 8 as reflected here. Then, this is a quadratic equation already. X squared minus 6x plus 8 equals 0. Then factoring out, we have factors x minus 4 and x minus 2 equated to 0. So we have x equals 4 or x equals 2. Checking for x equals 4, we go back to the original expression by substituting. Instead of writing x, we write 4. So we have 5 raised to 4 squared minus 6 times 4 equals 1 over 25 raised to 4. 5 raised to 16 minus 24 is equal to 5 raised to negative 2 raised to 4. So we have here 5 raised to negative 8 is equal to 5 raised to negative 8. This is a true statement. So x equals 4 is a solution to the exponential equation. For x equals 2, we have here 5 raised to 2 squared minus 6 times 2. That's 5 raised to 4 minus 12. And here on this side, 5 raised to negative 2 raised again to 4. That is 5 raised to negative 8. And if you can see here, 5 raised to 4 minus 12, this is negative 8. Obviously, it's true. So we have here, hence, x equals 4 and x equals 2 are the solutions to the given exponential equation. Moving on to enrichment activity. So we have the first number, 3 raised to x minus 2 equals 81. We are to solve the value of x. So for the solution, we need to find or to express 81 in terms of powers of 3. And 81 is equal actually to 3 raised to 4. So then they have the same base, 3. So we can equate their exponents, x minus 2 equals 4, giving us x equals 6. Checking. For x equals 6, we just simply substitute 3 raised to x minus 2. That becomes 3 raised to 6 minus 2. That's 3 raised to 4. And 3 raised to 4 is 81. True. Thus, x equals 6 is the solution to the given exponential equation. For number 2, 5 raised to 3x equals 625. Expressing both sides of the equation with the same base, Then we have 5 raised to 3x, so just copy. But 625 is actually 5 raised to 4, meaning 5 times 5 times 5 times 5 is 625. Then we have the same base, so we equate 3x equals 4, their exponents, giving us x equals 4/3. Checking, we just plug in the value, so this is a true statement. Thus, x equals 4/3 is the solution to the given exponential equation. Next problem, the third one, 10 raised to 2x minus 1 equals 1000. Solve for the value of x. We just copy, equals 1000. And we know that 1000, how many zeros? 3. That is, 1000 is a power of 10, or it's equal to 10 raised to 3. Then, these two expressions have already the same base, so the exponents must also be equal. So 2x minus 1 equals 3. Solving for x, we have 2x equals 4, giving us x equals 2. Then checking, 10 raised to 2 times 2 minus 1, that's 10 raised to 3, it's true. Thus, x equals 2 is the solution to the given exponential equation. For number 4, 5 raised to x minus 2 equals 5. Well, exponent here is 1, so we have x minus 2 equated to 1, x equals 3. Now let's check. 5 raised to 3 minus 2, that is 5 raised to 1, or simply 5, true. Thus, x minus 3 is the solution to the given exponential equation. The fifth one, we have 2 raised to x minus 3 equals 1/2 raised to 2x minus 3. We copy the left-hand side, but the 1/2 here, we can express it as the power of 2. We have 2 raised to negative 1. Then copy again the given exponent, 2x minus 3. They already have the same base. Let's just copy here. Wait. Here, we can simplify this. This is a little bit complicated, so let us simplify. 2 raised to negative 1 times negative 3, that becomes 3. Then, negative 1 times 2x, that becomes negative 2x. They have the same base, so we can equate x minus 3 equals 3 minus 2x. Collecting all the x's on this side, 3x. Then collecting all the constant on the right-hand side becomes 6. So x equals 2. For checking, x equals 2, we just plug in the value x equals 2. So 2 raised to 2 minus 3, that's 2 raised to negative 1. Then we have, is it equal to 1/2 raised to 2 times 2 minus 3? Yes, true. Thus, x equals 2 is the solution to the given exponential equation. So we have here the reference. And again, thank you for liking and sharing this learning activity video. And if you're not yet a subscriber, kindly subscribe down below. And if you have any comments for improvement, just comment down below and I will be happy to reply as soon as I can. This is Teacher Marichu saying stay happy, healthy, and safe. God bless us.